Okay, guys. Well, good news is we got a short week this week. We are not having scheduled classes on Friday. This is Easter weekend, and so we've got a scheduled day off Friday and a scheduled day off Monday. Now, the reason I'm telling that, it's important to note that your assessments are then due in the grade book by 11 a.m. on Thursday. So we've got a shorter week, so a little bit less material, but then that means that the timeline is shortened. So you've got two check ins that week, one day after the other. You're going to have to check in Wednesday either by coming to the classroom meet session if you got questions on Wednesday, or by sending me an email. Either one of those suffices. And then when this is in the grade book by 11 a.m. on Thursday, that'll be your second attendance check in. So make sure that you're keeping up with this material. What I wanted to do is go back to one of the problems that was on last week's assessment and deal with hydrates here. Some of you are still having problems with hydrates and you're a little confused by that. So I wanted to show you how it works, give you a little bit more practice on this, and then we'll assess this one set in Skyward. So let's take a quick look at that problem that we did last time around. Now, the first point here, though, is what is a hydrate? Now, if you look at a hydrate versus when you've driven the water off, they look different. Copper sulfate pentahydrate is a blue crystal. What that means is it has absorbed the water and it's holding it in that very stable configuration, and that's what gives it its blue color. If I heat that, not only am I going to drive off some mass by removing the water, but it's going to change the look of it. Copper sulfate, when it's completely dried out, is white in color. What's interesting here is if you add it to water, it'll turn blue again. It really wants to hold on to that water, and it doesn't stay in what we call an anhydrous state, meaning without water, for very long. It'll pick up water from the atmosphere or from any other source that it's got available to it. So that's what we're talking about doing here, is figuring out what this coefficient is for water when we write the formula. So how do we do that? Now, this last week's assessment question, it was the last question on the quiz, and it said, using the same information in the previous problem, what is the value of n? So I included the previous problem. What we've got here is a compound of barium chloride, and here I've got the letter N. That represents the number of moles of water attached to it. So what I told you is you've got 75 grams of the hydrate, and then when you heat it, you're only left with 63.9 grams of dry substance. That's called the anhydrate. So what is the percentage of water in the hydrate? What I'm going to do here is not worry about the percentage of water, but the value of N. So let's take a look at that real quick. First thing you want to do is figure out, what do you know? I give you the mass of the hydrate and what remains. What remains is the dry barium chloride. So the difference of those two numbers is what you lost. The 11.1 grams that you lost is the mass of water. So what I know here is I know the mass of water, I know the mass of barium chloride, and when those two are together, that's the mass of the hydrate. So it's really those last two numbers that I'm going to be using here. Next thing I'm going to do is convert it into moles. So I'm going to convert 63.9 grams of barium chloride into moles. And the way that I do that is I use the mole map and I look up those masses for barium and chloride. Barium has a mass of 137.33, and chlorine has a mass of 35.45, of which I've got 2. That's where I came up with that mass of 208.23. When I divide by that, I see a value of 0.307 moles. I do the same thing with water. I take that 11.1 grams and I divide that by its molar mass of 18.02, and I get that mole value of 0.615. So this is not really that much different from when we were solving empirical formulas, but you'll see the difference in a second here because I'm not really finding the whole empirical formula. I already know what the subscripts are in barium chloride and water. When I find that whole number ratio, I'm going to still divide by the smaller of the two numbers, and I'm going to get a 1-to-2 ratio. But I'm not looking for all the subscripts in the formula. I'm just looking for the value of n. The value n is either going to be equal to or greater than 1. So you're not going to have to do fancy math here. You're just looking for the value of n. The salt is going to be 1. The water is going to be either 1 or some multiple thereof. So when I find that 2, remember when you write that, that goes out front of water, and we call it barium chloride dihydrate. So that's how you indicate the formula of that hydrate. So whenever you're naming these, you simply just call it a hydrate and you put a prefix in front that tells you the number of water molecules attached. It's really that simple. What I'd like for you guys to remember, though, is when you're naming the compound, don't forget, does it need a Roman numeral, yes or no? Can you use a traditional name for it, yes or no? Things like that. I'm not really concerned if you choose to use a traditional or a stock name, but just note that there are some salts like iron, like copper, like cobalt that form multiple different forms of that ion. And so you're going to have to specify which form of the ion you have. So, pretty quick, pretty simple here. Here's what I want you guys to go do now. There's a practice set in page 20 of the packet I'd like for you to go through and do. Now, there are 7 problems on that page, but I only want you to do 6 of them. I want you to skip problem number 6. The data in that problem does not match up. So I'm going to have you guys skip that one. Otherwise, you'll get confused. So do 1 through 5 and then problem number 7. Those answers are posted on the website. And yes, Josie, I remembered to post those this time. So they're up on the website and running. Then I want you to do the assessment in Skyward. That'll be posted starting at noon on Wednesday. That way you have an opportunity, if you've got questions on some of those practice problems, you can come to the office hours and get those answered on Wednesday. I'm going to be back at the high school on Wednesday, so I'll have the board behind me. I can kind of show you how to go through those step by step if you have questions or concerns. Okay? So hope to see some of you on Wednesday with your questions. Don't forget your deadlines are moved up by a day so that you don't miss those deadlines. And good luck with these, and we will talk to you guys soon. So take care, be safe.